Our speaker this evening, feel free to stand up.
Oh, well, sure.
Our speaker this evening has a very diverse and unusual background. So, first off, he's one of the organizers of the Westport Mini Maker Fair and author of Mashup Patterns. Very good. Now, here's the unusual part. He has swam with sharks, helped tranquilize a wild lion, and stood down a charging grizzly. Whoa. By show of hands, has anyone done any of those three things? Which one?
One of the three.
Oh, good. Great answer. Okay. Now, the thing is, I'm not really supposed to say what company he's working at. So please welcome the Senior VP of Technology Infrastructure at a Fortune 500 bank in America, Mike Ogrinz.
Thanks very much. Thanks very much, guys, for having me out here tonight. And you know, that's very tactful, you, Eric. Hopefully, you have a spare room that my family can move into. I wanted to actually start by just continuing with the trivia, giving out a couple copies of the book. So it seems like I was trying to think of some good questions here, and you kind of covered some acronym ones. Maybe this is also sort of a little age test here, but let me. Okay, so for the copies of the book, the first question I'm going to ask, and again, same rules apply. And this is not related to the presentation at all tonight, just a general knowledge quest. Who can give me the 2 Hayes level commands for dialing a phone number?
ATTT.
And the second one?
ATTP.
Nice, well done, sir. Does anybody remember pulse dialing? I don't. I don't. If you can pass that down, that's great. And this gentleman here, you have a name tag on. Well, okay, all right. So Raul, you're still in it, even though you seem to know every acronym ever stated. We're not going to do something. Give me, and actually this is open to everyone, but I'm counting on you. Give me both the actual and humorous algorithms for ISDN.
ISDN protocol, right?
Right. Well, it's not, no. Yeah.
I think it's...
Everybody can answer. Get on your phones. I mean, it's not just, look, he's not come up with it immediately, so you stand a good chance. No, tell me what it stands. Tell me what the letters ISDN stand for. There's a real answer, and there's kind of like a funny answer.
Digital net. Yeah.
All right, now what's the funny one? What's the funny thing that we all used to say when we all tried to get ISDN? We'd all say that's not what it stands for. It really stands for
Standard Dialing Network.
That's not humorous, though. that may well have worked, but that was funny in my circle. All right. I'll give you guys another trivia question. The other thing I was looking for was it still does nothing. So let's see, one more. I don't want to go all night on trivia questions. So everyone in the room knows, because you're all fellow nerds like me, that except that guy, that answer to life, universe, and everything in Hitchhiker's Guide was 42. What was the question that was asked when Arthur did that? No, there was a mathematical question, and then when he heard the answer was 42, he says, "Oh, I always knew there was something fundamentally wrong with the universe."
6 times 7.
No, and that's why there's something fundamentally wrong with the universe, because the real question was.
What is the answer to everything?
The life, universe, and everything.
What is the meaning of the universe?
No, but I'm going to give you the book anyway, sir, because no one's coming up with it. It's gosh, now I'm blind. The question was, what do you get when you multiply 6 times 9? And the answer was 42, and that's why things are fundamentally wrong in the universe. Okay, so continuing on that thread of things fundamentally wrong with the universe. So I'm going to talk a little bit. Oh, for folks who are expecting, I know some of you guys were expecting a topic tonight on I think NoSQL versus SQL and databases services. So actually, this is not that talk, but you're lucky because I could sum that all up for you right now. The answer is CSV files. So now you don't have to go to the one. When Eric asked me if I could come and do a presentation tonight, he did say it has to have NoSQL in it, which I apparently completely misunderstood as something else. But so there will be no anyway. Sorry, these are the jokes. It is not going to get any better. Have another beer to increase my humor. Now, actually, I'm going to talk tonight about a little bit about. Now the books are gone for me to reference. a little bit about some of the subjects that I touched on in Mashup Patterns and how I practically applied them to the bank that I work at. Then, in the second half of the presentation, there is something also kind of tangentially related to development. It's a resource that is just going to come out of beta well, I suppose it's in beta now. We'll launch it in a couple weeks that I wanted to show you guys. And in the third half of the presentation, if we should have time, I have some other stuff to talk about, how the previous two parts, I should probably talk about checking people's math, but anyway, how the previous two parts of the presentation relate kind of to the changing role of IT. We have a nice sized audience, so if you guys want to interrupt me with a question, a comment, a non-derogatory statement, that's great. Again, I think the same rules for the trivia. You know, no reason to raise your hand, just shout it out. So if you can't tell by now, me kind of sitting up here all dorky, yes, I'm 100% nerd. That's me in the, I should have asked what was the name of this robot. That would have been a great trivia question.
B9.
The B9, excellent, sir. I have no book to give you. I give you a free business card later.
Who built this robot?
It's Lost in Space, right?
It is from Lost in Space, and I know Bob May was the guy inside. Dick Tufeld was the voice, and I cannot remember the Japanese set designer's name who built it. Darn it, that's nagging at me now. I should know that off the top of my head. Who also designed Robbie the Robot from Forbidden Planet, which I'm also in the process of building. All right, enough about this garbage. Let's get on to the presentation. I'm happy to tell you all this stuff how that building that. So actually, in the aforementioned book that I said I'm not going to mention, but now on like my 6th or 7th reference to, I talked about, and the book is, as some gentleman pointed out to me here earlier, isn't that book really old? Didn't you? I'm like, yes. The book is a few years old, but you know, large corporations, for those of you who are not familiar, we tend to lag like anything interesting by like 6 years. So we're actually ahead of the curve that we're using some of this technology. But I talked about basically the database that was the web, essentially, and different ways that we could leverage that information. And I used to, walk around at work during the day and say, geez, there's like money on the floor if we could just be bothered, to pick it up. And there are problems that we could solve with some of the technologies that I'm going to go into. So I went and I categorized and talked about these topics. And again, it's interesting, when the book did come out in 2009, financial markets, et cetera, we were kind of going through a rough phase. And I think that the technology did kind of get put on hold a little bit. Companies were just, people were kind of reluctant. Okay, what are you doing? I'm just trying to keep my job here, heads down, doing things the normal way. And you may have seen that in the adoption of things like, NoSQL, non-relational data stores and other technologies, OpenSpan, OpenFlow, et cetera. So I think that the innovation programs that a lot of companies now are actually picking up speed. So what I'm going to talk about in the first part of my presentation is just one of the many ways that this technology can be used, and give you guys a real-world example. I used to call it API enabler. The parlance now in the industry seems to be to call it a synthetic API. And basically, what a synthetic API is, it's talking about building an API on a data source, like perhaps the web, perhaps XML, perhaps RSS feeds, or some other non-structured data where an API doesn't already exist. So the problem du jour, the problem that I faced in my work environment was that the organization where I work has grown largely by acquisition. It hasn't grown organically. So what you find, and again, maybe many of you have seen this, what happens in mergers and acquisitions is that, right, the existing company that's acquired or the acquiree, there's duplication of systems. And generally the sales pitch is, well, we're going to put these things together and there's going to be economies and we're going to simplify the environment, and probably that means we're going to cut costs and reduce headcount. It's been my experience that doesn't usually happen. What happens is a lot of times multiple systems survive. That leads to increased confusion internally. That leads to obviously inconsistencies because the systems were branded for maybe the company pre-acquisition. It's never rebranded. And then of course you have this whole little sort of sneaker net internally where when someone wants to know how to get something done, they just got to kind of ask their friends, and your ability to get stuff done at work is more about your social network than it is about, oh, I know where to go to find the problem. So this was an issue that we had. We had as I said on the previous slide, there are about 14 different catalog systems in the firm. And I should mention now too that just like the name of my employer is top secret, I can't show you any of the real screens that because I'd probably spontaneously combust. So what I did was I had a friend of mine who's a designer put together a lot of these mock-ups. They are very close to what the real screens look like in the sense that they do, I think, successfully portray what a lot of the problems are. So for example, other than the fact that this looks, we didn't intentionally make these things look ugly. It's just like a great side benefit. But if you look at just this sample system here, right? I mean, okay, there's a search box up there. Some of these names, excuse me, I don't know. I know there's some things like promotional items with brand. I don't know what that means. You can imagine you probably rely on that search a lot because to click through here and explore all these subcategories to find what you want, I think like software and things, things that would be really easy are not easy to find here. And the functionality is very limited. I'll get into that in a second. So when you went to order something, some items, and this again is a real world example, even though we've shuffled the fields in the UI around a bit here. You had to fill, like let's say you're gonna order a copy of Adobe Acrobat. You'd have to fill out 5 screenfuls worth of information to get Acrobat. And it's things that that the system should already know about you. I think here we were generous and we pre-filled in my name, but in reality the system would want to know who you are, right? You're logged into the system, it should know who you are, what your computer is, what OS you have on that computer. And I used to tell people, like, if I got to go through 5 pages to order a copy of Acrobat or to order something, I don't care what it is. By the time I get to that 5th page, I'm buying it because who wants to go through all that and then toss it away at the end? And by the way, if you were going to order a copy of Adobe Photoshop, even after you filled out all these questions, you'd have to fill out exactly the same questions over again for the next product. And again, here's another system. This system was really great. It has no search functionality whatsoever. You got to totally click and explore it yourself. Again, all the words are some of them are shared. Some of the categories, this one at least has a software category. But you can imagine there's this same problem filling out multiple forms. You can imagine it's a productivity drain. So I was lucky enough that there were some better examples on the web, like the fact that anyone who's done any shopping at all in their private life would probably go home and say, I don't understand, it's so easy to go on to go on Amazon or to go on Apple. And these are companies that they want your business, right? It's totally discretionary whether you go to Apple or Amazon and you buy something. So they have to, you could say, well, they have to make it look nice because they want you to shop there, they want you to buy there. And so you could say, well, so people are forced to use this, right? We don't have to make it look nice or work well. I mean, it's kind of silly, right? I mean, the fact that these systems look and work so well, they're so frictionless for the user, should be an inspiration to the internal systems that we try. But they're not. A lot of times, I think we fall into this trap where you have a captive audience, and the business users are just thirsty for a solution, and they'll crawl over broken glass to get it. And so the UI becomes an afterthought, which is really unfortunate. So our goals were to obviously collapse all these 14 systems into one to fix the UI, and our mantra was, we wanted it Apple simple and Amazon friendly. I think you could switch the company names there and you get basically the same stuff. We wanted a shopping cart, we wanted bundles, we wanted a knowledge base. So what does all that mean? So the idea that I was saying earlier, where you'd order an item, you'd have to fill out 5 pages of information. You'd order another item, 5 pages of information. We didn't want that. We wanted the experience where you could put a bunch of stuff in a cart. I mean, it's not rocket science, right? And then you could decide maybe you wanted something, maybe you didn't, and you'd get to the end and there'd be some kind of seamless checkout process. We wanted bundles because a lot of development teams, let's say, as an example, when people would start on my team, we'd say, okay, look, you need this JDK installed, you need Eclipse, and you need XYZ, you need the Tortoise client, and all these other items. And you shouldn't have to just go out on the internal catalog and order this stuff. You should just be able to say, I want like the new developer bundle for Mike's team, and order it and get that. And we wanted the ability for teams not just to have bundles that we built, but to make their own bundles. We wanted more stats and data, which I'll get into later, about who was buying what products were being combined, get some more metrics on that. And we wanted an integrated knowledge base too, because I think I have a product detail page coming up later. But if I jump backwards here, this doesn't really tell you anything about the product that you're ordering. We wanted product detail pages that pulled from the knowledge base sources we already had to tell you a little bit about what you were getting, to make sure you were kind of ordering the right product, because again, the mystery firm that I work at is pretty big. We're kind of like a museum. We have one of everything. So it would be nice if you could give people some kind of feedback to let them know, this is what the product is, or here's some recommended alternatives, and here's some internal knowledge articles we have about, that might help you understand which products to choose for your needs. I just want to pause for a second. The folks who are standing in the back, there are some seats. There are like 2 seats up front here. There's a couple in the middle here. If you guys want to sit down, be more comfortable. If you want to, if other people want to leave already and give up their seats, I totally understand. So the challenges, you guys could probably imagine what most of these things would be. First of all, in a big company, as I mentioned, growth by acquisition, most of these systems are supported by different teams internally. Those guys have their own agendas, they have their own timelines for delivering their own enhancements, their own functionality. The systems are in some cases on different technologies. Let's just say, Java and .NET being the most prevalent, because these things have been around for a while. They're not incentivized really to work together. There's no reason that they'd want to integrate. I mean, of course, if they were thinking about the customer, right, they'd want to get together and integrate these things. But a lot of times that's not the way that the organization of IT somehow coalesces its focus. A lot of times it's on the budgets and delivery of individual timeline items and losing track of the customer. So you have different back-end fulfillment systems. So you have, in some cases, let's say you order a telephone, and it might be what we call a punch-out site. So when you order that phone, once you specify the carrier, Verizon or AT&T, for example, you go off to a site that's set up specifically for us, but it's at a different vendor site. The synonym problem is interesting. Again, if you think of those different category pages I had, and I mentioned one says computer software and one doesn't, maybe one said like application software or something like that. So you have to think, okay, I'm going to collapse this data. How am I going to get around the fact that, first of all, no one's going to have an identical set of category names. Someone's going to have desktop applications, and someone's going to have software. Someone's going to have computer hardware, and another person's just going to say equipment or something like that. You also might have the synonym issue on product names themselves. Someone might just say Acrobat, or someone might say Adobe, PDF. The big thing, no existing APIs. Again, why would I create an API to a system when, at the time of me writing this system, the notion was maybe, a little bit pie in the sky, but a lot of times when people write this catalog system, they think they're writing a definitive system at the time. And I think most of us would assume that if we're going to write a public API, we're going to assume that we're going to give up some level of control. Maybe that's the wrong, well, I know it's the wrong way to think about it, right? You're supposed to kind of have this public API to help empower other people to build better products, to basically admit that the functionality I can provide stops here, and if people want to go here, I'm going to give them the ability. But again, in my organization at least, there's not really an incentive to make the APIs. If you told a customer, well, we're holding up your release because we're building this API, because somebody else in another department might want to use this functionality, the response you would likely get would be along the lines of, well, I don't pay for them. Why, that's not my budget. Why am I spending my money to make someone else's life, easier? And it's a shame in a way that, again, that technology sometimes has a lot of these issues. I like to say at the end of the day, it's one stock ticker. So really, this shouldn't happen, but it does happen, and all we can really think about is dealing with the problem, I think, and sometimes it could be solved with code, and sometimes it could be solved with a little bit of what I put on the bottom, the regular political stuff, and that's, again, the stuff I mentioned. People don't necessarily want to cooperate, they see any challenge, any improvement you want to make to their system might be interpreted as a challenge to their authority to kind of manage that system, or it's this protectionist notion around the data, like the data is my thing. I've got the data. If I open the data up to you, you're going to mess it up, and that's going to mess up my application. So rather than put the controls in place, there's always that idea about just kind of putting up this wall instead. So this is a good time to talk about synthetic APIs. So I guess the short version is I had someone come to me who was a little bit visionary, who known that I worked on the book and had seen some examples I'd done with the technology, and said, Mike, is there some way that we could put these 14 apps together? And I said, yeah. So, and this is not really meant to be as I said, it's not really meant to be a mashup presentation, but we're going to kind of skim the edge of the definition, and I'm happy to go into more detail if folks want either now or afterwards. But this person said, can we use some of the stuff you talked about in the book to build these APIs on these systems and put something together? And I said, absolutely. And this was a slide I kind of put together to give him a little idea of how that would work. So it's not rocket science. I mean, conceptually, ideally, the systems would have had existing APIs, whether they would have been, REST or SOAP is kind of immaterial, but there would have been something there. And as I've already told you guys, that didn't exist. Another approach is to say, well, can we get like database access to these systems? Can I just build my own system? Can I look at all these different databases? Somehow do some EII project, coalesce them into one database, somehow rationalize the synonym problems, etc., and then somehow put data into the, back in there to have these orders triggered. And, again, I know you folks are like database savvy. You can imagine there are all kinds of problems with that. A lot of logic for validations is existing only on the front end. Let's just talk about schema design for a second, and then I use the term very loosely. Some of these systems had kind of a decent schema, and some you would look at and say, okay, hello, fifth normal form. No, you look at it and you say, okay, this is, it's not going to work. There was just, and obviously there's app logic in stored procedures, as I mentioned, on the front end, and sometimes in middleware pieces. So that doesn't necessarily, work. Having access to the data, even if teams were going to give it to you, which, as I mentioned, they're reluctant, wouldn't work. So what does that leave you with? That leaves you with basically at the glass, at the top. And what an API enabling platform would do to allow you to create a synthetic API is interact with some kind of an environment. I'll go into detail and again in another minute, but some kind of a tool or an environment where, let's say, for lack of a better word, you could script the browser. Not really like Selenium, but if you consider the structure of the web page, some way that you could interact with that web page and you could script that, you could programmatically control that, and then you could expose that as an API. So normally, some people might be thinking, normally when I talk about this, people just say, like, isn't that screen scraping? And no, but it may, because who knew the answer to ATDT and stuff? Like, so clearly, like, you remember like mainframes and screen scraping and stuff like this. We all know the concept, right? When you look at like, here's like position XY on this 3270 screen here, and I'm going to grab the data from here, and I'm going to put some data in here. And there are tools that still work that way, the API-enabled mainframe apps. But we've gotten to a much higher level of sophistication these days, thanks in part to just the structure of HTML. If you think about it, you probably have apps where you work or that you interact with, where even if the UI does change occasionally, maybe the underlying form ID elements don't change, maybe the underlying CSS class names don't change, maybe the structure of the items on of the elements or the nesting doesn't change. You put all those things together, and because the DOM has a little bit more structure, it's possible to build something here and have it be a little bit more resilient. Now, the other thing I should mention here is that doesn't mean that it still can't break. And I think this is the other challenge that I have in explaining this to people. You would not use this technology to build a trading system. You would not use this technology to build some mission critical system. Because, again, there can still be some kind of wholesale change that will break what you've written. And hopefully, you can at least have some level of communication with the teams that are controlling these underlying systems, that you're at least, if you can't, sort of pre-test for some of these things in a dev or a UAT environment, you can at least know it's coming. And the other nice thing is, with this kind of approach, the 14 systems don't necessarily go away. So if there is a problem, you can at least point people back to those underlying systems, as opposed to just saying, throwing up your hands and saying, well, it doesn't work, we're going to have to fix it. So again, as a developer myself, I had a little bit of a hard time coming to terms with this, because I'm used to writing a line of code, and you execute that code the first time, and the 10,000th time it executes the same way, and this isn't exactly like that. I call it sort of like there's a brittleness factor. It really depends a lot on the type of site that you're building these APIs against. But some are more conducive to to the API automatically adjusting for changes than for others. It really depends on the way the site is built and how the updates to it are made. So again, the traditional approach would have been use an API. Well, there wasn't an API. Again, database. I mentioned the logic is split in multiple places. That's not a factor. And rewriting the applications to either consolidate that. You can imagine. Again, I work for a big company, but we never have any money. So I know you're all thinking, but there's ATM. I don't get the ATM fees. But seriously, you're not going to get business sponsors say, we're going to rewrite these 14 applications. Even if you probably made the case that if you did a usability study and you looked at time waste, or you look at misordered products or return products, or abandoned or unused products, or license recovery on things that people didn't want because they misordered it, it's a very big problem to take that route. So the easier thing is, I guess, to kind of paraphrase Grace Hopper, would be to just not ask permission and just go ahead and build all the APIs that you need against the systems yourself. As I mentioned, when I say rapid to change here, obviously, I don't mean the underlying systems. They tend to not change at all, which is part of the problem. But what's nice is if there are changes with synthetic APIs, it's generally easy for you to accommodate and to handle those changes. Oh, one other thing I wanted to mention here is also important, is leveraging the security model. Because when you are going through the glass, as it were, whatever authentications and validations happen, they still happen. So you don't have to worry about how the underlying system was architected in terms of security or validation. All that stuff is still going to happen. So I did not want this to be like a commercial for products in this space, which is why I kind of just put, for the commercial stuff, generic names here. But I did feel that it was important to at least kind of touch on the fact that this is real stuff, and there are different products in this space, and what their focus is and what they can do kind of varies based on where the vendors have chosen to focus their attention. So product A is actually the product I use to build this solution. And this is a class of product, if you will, that basically is a fully scriptable web browser, if you think about it. There's no visual component when the thing, it runs sort of like as a headless browser on a server somewhere. So you build your synthetic API there, you point it to the website, you navigate the website or sites, because you can grab data from site A and then use that as an input into site B, and then get data out and use that to site C, but you build your API that way. And any JavaScript that has to happen, any filtering, for example, maybe you tell the page, I don't want you to load images, because why? It's running headless, it would never make any difference. Or maybe you want to take snapshots of the page. Anyway, it's a fully scriptable browser environment. Product B is a product that, so I would call product A, I would call it like a synthetic API enabler. It lets you build APIs where they don't already exist. Sort of a level above that, product B I would call a synthetic API platform. It doesn't necessarily let you create APIs. It lets you sort of chain and filter them and maybe get, do different conversions on the output or conversions on the input. So if you think of it, it's almost like just putting little blocks together on a Visio diagram where each one of those blocks is pre-existing web services or database calls. Product C is interesting. And as I said, if someone really wants to know what names in this space because you have a use case in mind, I'm happy to tell you guys later or now. Product C is interesting because sometimes you want to build a synthetic API not against one site or even 14 sites, which is what we were doing, which was manageable for one person to sit there and manually build these APIs. Let's say you wanted to build an API that went out and grabbed the top headline stories from every local newspaper in the States. And let's just assume you were lucky enough to have a list of those URLs. You can imagine that that's probably, even with like the decline of papers today, that's probably in the thousands. So you would not want to sit there and build 1,000 APIs and visit 1,000 sites. So there are some sites that you can train and use some NLP technology and some other AI and probably some neural network stuff also. But basically you can tell it, you can train it on like 10 sites, this is what the headlines look like on a site. You can give it the list of URLs and it will go out and automatically collect all that stuff for you and do a lot of the heavy lifting for you. And the first three all really pertain to web-based applications. So people have said, well, what about, is there any way if I have like a vendor product that's a thick client desktop application, can I get data out of that? Can I get an API out of that? And yes, there actually is one product that hooks into the Windows OS and can let you pull data out of the existing UI and also let you inject functionality in, which is it's actually pretty slick. You can change buttons around on the Windows calculator, add your own. It's really neat and unfortunately ridiculously expensive, but the technology does exist. If you're in a bind, sometimes sometimes you have to write the check, I guess. I had this picture here. I initially took this out. I think I blurred a lot of the vendor name and stuff on there. But just to give you an idea what product A is like, just the pointer thing going to work here for me. So this is not writing code. Sometimes I wish it was because I think it would be much more straightforward. In the middle section here, this is part of a web page. So one of the ways you interact with this API maker is you visit the web page and you click on the parts that you want. Down here in this box, down here is the DOM. You can also click down here because sometimes you don't necessarily want to extract a list of. I think this is a list of distribution groups. Sometimes if it's a select box like I have right here, you actually want the value that's sent to the server. You don't want the display value. So you can interact with both parts of the DOM here, the visible and sort of the structural underneath. And then up top, you're building this list of steps, similar to what I said earlier. It's like just building a flow chart in Visio, and you can loop through tags. You can loop through your tag structure again via the visible structure. You can say for every row in the table, or you can say for every div, or and really just ad infinitum down to the level of nesting that you do. And again, this is the environment. It's really not very complicated. One of the things I wanted to convey was that the structure of these tools has gotten to the level now. This is by no means like like case tools, like computer-aided software engineering, which was going to kill all of us, right? You were going to draw the picture and then push a button. I think, does anybody know Ed Jordan? Like he wrote this book, Decline and Fall, the American Programmer, because he said case tools were going to be so good. It was going to be like how The Simpsons gets drawn in Korea. Like we were gonna write specs so great that we were going to send it off to somewhere in the East, and they were going to put it in with these case tools, and they were going to push a button, and the code was going to come back, and it was going to put the American programmer out of business. Not really stopping for a minute to think that if you really, aside from the fact that maybe it helps, when are the specs ever frozen? But if the specs were really that good, you've probably written the program by that point. But what I love about Ed Jordan is, I want to say this right to the camera, Ed, in case you're watching this. What I love is that when he did realize that he was wrong, he wrote another book called The Rise and Resurrection of the American Programmer. And people bought both books. I can't understand that. Anyway. I thought maybe I saw him. Was there any question about just this environment or anything? No? All right, cool. So now I do feel more comfortable mentioning stuff in the FOSS, the open source space here, because I'm obviously not lining my pockets plugging it. Your options are not as broad, unfortunately, but there are a lot of interesting solutions here. One of the things for the Python crowd is beautiful soup. Java developers, JSoup's a good equivalent. If you just need to mine data from websites, the soup products there are excellent. They have jQuery-like selectors, so it's really convenient. And if you wanted to build an API just to extract data, very valuable. It sounds like they're having a parade out there. Cool. There are actually scriptable headless browser environments. Phantom.js, GhostPy can do some of the JavaScript execution. Convertigo is interesting. A little while ago, I would have had them, anonymously on the previous slide, but they actually now do have a multi-license, so they have a free version. Very similar tool, in terms of being able to come in here, build something like this interactively. They're Eclipse based, which is nice, and WebKit, and expose it as APIs, REST or SOAP, and then Scrapey, which is, again, another nice little open source. It's a crawler and an extraction tool, and I'll talk a little bit more about that one later. So the general point, I guess I'm kind of getting to in terms of Mike's up there and he's telling us about this kind of a presentation. He's telling you he can get us this data, but sometimes it breaks. So how really is he going to seriously do this at the office? I mean, I've changed my philosophy a little bit because of this technology, and I won't butcher Voltaire's, my good buddy Voltaire there. I won't butcher the French, but the best is the enemy of the good, right? That's not something a lot of times that we talk about in software development. We just expect consistency is the goal, not this notion that you can suffice and get to a level where you can meet a business requirement, and that's good enough. And if it breaks, if the value you get exceeds the cost of the occasional remediation, then why wouldn't you do it? And I want to point out that Voltaire was serious when he said this, because I mean, look at those pants. So anyway, or as Patton said, again, have another beer. These are jokes. Okay. Yeah, thanks. So we created this. So to deliver the solution, we created the DOM-driven synthetic APIs. Now we had to actually mine the data from the catalogs that we were collecting, because we didn't just want, when you ordered something, when you search for something, we didn't want to go out and we could have, right? We could have said, when you put in Adobe Acrobat, let's build an API for search against catalog A and B and C and D, and let's go out and send that search request out to all those different catalogs. Let's get the results back. Let's normalize and let's figure out which system, if hopefully just one has it, and then let's direct your orders to that. We said, no, that's not going to be performant. So what we did was we wrote an API to crawl each of the catalogs so that we could coalesce it and normalize it ourselves not during peak hours. This also meant dealing with, yes, sir?
Why would you think that would not be performant? Because that's what I was thinking, was just having a front end and then having everything else as a data fabric.
Sure. So, well, the basic reason is because we knew the performance of the existing systems already, and the performance was only going to be as good as the slowest system, because if you executed a search, you had to wait until you heard back from everyone, because you couldn't tell whether or not the product existed or where it was. So it was really, in this case, the chain weakest link story. So we said it's not going to work because the slowest system is not fast enough to be acceptable. So even if we spun up a thread for each one of them, it still wasn't going to come back. You also had the problem that we wanted to fix, which was the synonym problem. We wanted to normalize the names. So down here on the bottom, when I say some admin stuff, I don't know where this is here, that was one of the things that we did. We said, for example, we went to each system. We didn't just crawl the items in the catalogs. We crawled the catalog, like the category names. And so we went to some business analysts and we said, look, what do you want in the ideal shopping experience internally? What do you want the category names to be? And then, okay, here's an admin screen so that you can say in this system, if the final name is software, okay, for each one of the systems we crawl, one of your admin jobs is to say, okay, computer programs maps to software, and application programs maps to software. And you can imagine the categories in those underlying systems really never changed. They were pretty static. but once we were in control of, if you will, of the data ourselves, we could offer that functionality. The other reason for collapsing the search was because we also wanted to provide with, we just use Solr, but we wanted to provide our own search experience. Also, it allowed us to add synonyms for product names. So you would have, as an example, a web camera. So the products in the catalog, they'd be the actual product name. There'd be like Logitech C30, or there'd be some other Microsoft camera like that. We knew that people were going to search on webcam. They weren't going to search for the specific web camera name. So again, another admin thing we did was we gave the administrators the ability to say, okay, here's a catalog, here's a product in the catalog, and you can attach a list of synonyms to it. And that was really, for that to work, we had to control the data. The other major thing I think that we did was we didn't just want to build like the 15th catalog and then have people build the 16th and such after that. So the UI layer that my team created was designed to be universal. And what I mean by that is we defined standard API interfaces that we expected from catalog providers. Now, for these initial 14 catalogs, we built those APIs ourselves to conform to our own specifications. So what that means is there would have been an API for crawl the catalog, and you would pass in, I don't know, maybe a list of the categories that you were interested in. And if someone else came along with system number 15 or 16 or 17 and they said, well, we want to integrate it with your system, we would say, okay, you have to provide an API for crawl the catalog, and it's got to take a category or something. Or you've got to provide an API for here's how you order an item, and here's the item number, or here's how you cancel an item or request status on order. So they were all plain text, REST-based APIs, so that when the system was out there and living in production, once you wanted to onboard a system, once you verified that that system exposed all the correct REST APIs, then it was just a matter of going to an admin screen and saying, okay, add system number 15. Okay, what's the URL of its order API? Here it is. You fill out all those URLs and poof, you'd onboarded this system. So it was designed to be the last catalog. And then, behold, also not a final picture, but very close to what it looks like, the final screens. So, again, addressing a lot of the shortcomings of the existing application, we did things like provide, you can see here, we provided the bundles so that people could group together commonly ordered items. We provided, well, basically 3 levels for people to find items that they wanted to order. One would be via sort of the bundles here. One was the search. And then there's a little drop down here that kind of lets them drop down and explore the categories. And I think that's another issue. If you look at sort of the before and after, again, not rocket science to say that looks bad and that looks good. The challenge is, getting from here to here, and then having the APIs to leverage the data. And could this team, look at this mock-up and say, of course, we want to go back. We can make it look that way. Yeah, but the reality is, I've been using these systems probably for 5 or 6 years, and those changes never happen. I don't know why they never happen. Again, for some of the political and technical and other manpower and resource-related issues, it didn't happen. And I wish, in many ways, that we could just fix and collapse these systems. But designing this building the APIs, designing the system, designing all the admin functionality, largely helped by the fact that you could build these APIs in a dynamic way without really requiring hardcore developers to do it. The whole project took, I think, 3 months for primary development and about another 3 months to both test it and for the administrators to work through some issues like collapsing the categories and setting up the synonyms. The product detail page went from something like this. Your eyes are fine, I blurred that on purpose. Something like this that doesn't really tell you anything about the product, and you can imagine whatever that thing is there that's blurry and that's in red, probably something to make you feel bad about buying it. To something like this, where we show you a picture. Over here on the product detail side, this is where we went out and we looked at that internal knowledge base and we said, hey, as long as you're looking at Acrobat, why don't we tell you what knowledge base articles we have? And once, I think you'll find, once you sort of have these APIs, or you can imagine, all of a sudden, being the sun source for like all this ordering data, there was a lot of functionality that we could add that the underlying systems couldn't, which is kind of crazy when you think about it. How is it possible that you could do more than they did when they're giving you the API? Well, for starters, we have this simple little thing up here for quantity. And maybe it doesn't make sense for Acrobat to order multiples. But if you're ordering, SIM modules or DIMMs or something, it probably does, or batteries, or et cetera. So they never had quantity. So that point about, you order a product, you got to fill out 5 pages. It didn't matter if you were ordering the same product over and over. It's still 5 pages of data. Once you have an API to order that product, the quantity is nothing, right? It's a for loop over calling that API. So we were able to incorporate that functionality. Once you have, you had these islands where, someone ordered something from system 1 and they ordered another thing from system 2 and system 3, and those things never talked to one another. Once we knew that we were calling the APIs on these different systems, we could add frequently ordered together because we knew who was ordering the same stuff at the same time. So it became really powerful. The other thing is that's that 5-page checkout thing. So maybe you're wondering, like, how do you get around that? If the underlying system asks for 5 pages of information, how does your API not ask for 5 pages of information? So there's 2 ways. The first thing is you find out that most of that stuff is garbage. Of course it is. You can imagine that nobody needed. We went around and we asked the people who fulfilled the orders, do you look at these fields? No. I mean, generally the reality was that it was the comments section in the very end where you hope to explain clearly enough what you were trying to get so that someone, after they skip the first 4 pages of information, says, oh, he's trying to order Acrobat. Okay, give it to him. I understand. So the first thing was to try and eliminate all the fields, obviously, that had crept in over the years that weren't needed. And when you were dealing with the individual development teams, maybe they would take these fields off, maybe they wouldn't. The key thing is if you're building the API, you don't have to pass this stuff in. Or, ideally, you find other systems that already know this information. So a key tenet, right, in building an application is never ask the user to supply something that the system should already know. That was not followed in a lot of these underlying systems. So we went out and we looked at other systems. We looked at a system that knew what computers you had assigned to you and what OSs were assigned to them. We looked at another system that said, are you work at home or not? So we knew what your address was, and we pre-filled as much of that stuff in as possible. And it seems, pretty simple in retrospect to think about it, but that idea about filling out the same questions over and over again, guess what? We just stored it, we bound it to the session or whatever, so if we knew you were ordering the same stuff, we didn't have to ask you multiple times. And we had one checkout page. You put the items in your cart and off you went. Now, what the systems previously did was they would ask you multiple questions, as I said, like over and over, that were redundant. What we decided to do was, and this section is actually pretty much non-existent today. I think it's like a sample, it's an address field. We said, look, if there are questions that we're going to ask that are common to every product, like where do you want it shipped, we're just going to ask you once up top here. And then we're going to look at all the questions that the items in your cart want. And so we're going to break those out specifically for each item. So you can see, like this thing, it's a little bit blurry, but it says install new phone line. It's probably asking you, your location. And this one says, I think, add new voicemail distribution list, and it wants to know your phone number. So we would have to ask you some item-specific questions, but we break it out in a way that made sense. And then what happens under the covers is, once we have all that information, we basically look at the items in the catalog. We look at what source system they came from, and we have that database of REST-defined calls to order the item. And we just fire off the call to each system respectively. And our API returns a status code. How you deal with something unexpected, like the underlying system is down, we would basically just tell them, look, there's a problem ordering this item. We knew the source. We would say, please order it directly from, and we'd give you the name of the source. So that's the beauty of not getting a phone call at 2 a.m. when the system is down, because it's relying on these other systems. If they have a problem or if it fails for some reason, they get directed back to that site. And of course, if they go there and there's a problem, there's an outage, hopefully they get a message and they would come back here and order it. It really doesn't matter which system which system they order it from. I mentioned that about reducing data entry. So I stole this shamelessly from Gartner the other day. They were talking about their top 10 technology trends. I think the last thing I wanted to mention for this part of the prezo is on time is that Gartner calls this this section in the middle intelligence everywhere, and they kind of have a little bit different meaning for some of these terms than necessarily I would give them. But in terms of this pervasive and invisible analytics, my interpretation of that really is like situational awareness, the application knowing a lot about you and what you're trying to do and making recommendations appropriately. So the idea being how it relates to the ordering platform is we would know where you are. We know who you are. We can look at other systems. We can mash in, if you will, other bits of information about you. And we can tailor the UI and what the catalog shows you based on, let's say, what geographic region you're in. Things that couldn't be done before are things that we could do with this approach. Yeah, so conclusions, I guess, on this bit. Contextually relevant applications, I already mentioned. The key takeaway, I guess, is that there's probably a ton of data in your organization beyond what's in databases, or it's expressed from the database in a much more meaningful way than someone who has direct access to the data could necessarily, could perhaps intuit from direct access to the data. And it really is, again, I mentioned like a 3-month time to craft this. It really is an incredible, there's incredible potential for getting unique data and increasing the productivity of your development organization by building these APIs and combining these disparate data sources. Again, right now a lot of folks just have SneakerNet, or they use Excel as kind of a cheap stand-in for this, right? They copy and paste data from multiple sources. There is a way to automate that, so anytime you find yourself working or you find a business peer working and grabbing information from here and swiveling over here and pasting it here and grabbing it here, the key takeaway I'd like you to have on this part is there's probably a way that can be automated. It could be exposed as an API, it could be exposed as, it could be written to a database, it could be exposed as an Excel or a PDF. But it's very easy to use this as an automation tool for productivity. So, and that's like, boy, this next half better go a lot quicker than that half. Any questions on, I will have a little Q&A period at the end, but any like burning question right now about that before I jump on? Again, anything major we could keep at the end. Cool. I'm going to move along in the interest of time. So a completely different use now for the technology. Some of you folks may be familiar with this concept of the deep web. So what I was just talking about is an example. You have this catalog, and you can order items from the catalog, but you're not seeing what's in the database. The information that's actually in that underlying database can be very valuable, but how can you get to it? An example that I like to give is, let's say you were going to buy an airline ticket from Kayak or something, or Travelocity. So you get all the way up to where you buy a seat, and you look at the number of seats, and you're like, oh, this airline is flying at like 50% capacity. Well, what if you could actually, for every airline, what if every day you could go into the web and you could book a flight on every airline from, I don't know, Boston to LA, from LA to Singapore, from New York to London, and what if you could sort of like virtually take it up to that seat selection part, and for every airline, for every one of those flights, you could capture what percentage of seats were available or not available. You can imagine at the end of like a month, you would have this really cool data set, because you'd be able to look at it and you'd be able to say, look, Delta is flying at an average of 50% capacity when all the other carriers are flying at 80% capacity. From a trader's perspective, I wouldn't necessarily trade exclusively on that, but that would be a pretty interesting piece of information to know. And it's, as I said, it's sitting out there in public. You could grab it. The question is, it'd be this Herculean task if you had to do it manually. But you can imagine if you built APIs against the an airline website, that you can collect that data yourself. And actually, the airline example is a little bit contrived because you actually can license the Sabre data, but you can imagine looking at products, trying to virtually order products, seeing if it's in stock or not, maybe understand if the channel was empty, if there was a new product coming out. So that's, again, up here, that visible web, ordering those airline tickets, that's in the 4%. Down here is this huge chunk of all the seat availabilities for all the different flights that's hidden. Call this the content aggregation pattern in the book. So now, like, dun dun dun, Mike's like secret side project. So how many people have seen or used or heard about Programmable Web? So John Muser, who founded this, he actually, great guy. He's Eric and I are in a club with him, and gave me the quote for the cover of Mashup Patterns. So he had the foresight, like, I don't know, like 7 or 8 years ago, to start the web's first, I think, online API directory. And when the book came out, I think he had like 2,000 APIs in there. So I mean, he was really ahead of his time. Now though, it's 4 years later, 5 years later, and he's got 12,000, almost 13,000 APIs. You could expect maybe he'd have a little bit more than that. So how do they get these APIs? People submit them. It's a hand-curated list. And what that reminds me of is Yahoo. In the early days of Yahoo, everything was hand-curated. And God, who remembers how bad, like, Yahoo, we all used it, right?
Yeah.
Search results were in alphabetical order, I think, at one point. What the heck? I'm definitely browsing categories and stuff was. And it was, yeah, I know, right? Like dark times. And so how did that work out for Yahoo? We know, right? They got out of the search business, obviously. And yet here's Programmable Web still sitting here with this hand-curated index. And I asked, so Lucent bought Programmable Web. I don't feel so bad kind of ragging on it a little bit because John is out of the day-to-day of it now for a few years. But so Lucent bought Programmable Web, and I wrote this blog post at the time saying, how long were people going to like just sit there and use a hand-curated list? When was somebody going to programmatically figure out how to crawl the web and build this? And I kind of waited, thinking it was going to happen, and waited, and it never happened. And Programmable Web just kind of just like went along like a tourist. And so finally I said, I'm going to go out and I'm going to crawl the web. I'm going to try and build a better thing programmatically, an API directory. There was a little bit of bad news. I mentioned so far building these synthetic APIs against internal systems. There is no reason you can't go out and build a synthetic API against eBay or Amazon or so. I mean, they have APIs, but against some other site, maybe Netflix now that they've decided to pull their API back. And the law was really gray for a while here. It was sort of like you're putting it on the web, it's all up for grabs. Eventually, and this is the only case I really know that speaks specifically to this issue, one of the many people that was crawling Craigslist and improving it, not that hard to do, excuse me. They, Craigslist finally, got into a legal battle with them, and Craigslist won. And the court basically said, this will probably stifle innovation, but the law is the law, and so it's going to have to stand. So the idea of going out, so the idea of like saying I'm going to start my database already with 12,000 APIs because look, that's what they've got, and I can crawl their catalog. I kind of had to throw that out. It didn't really seem fair anyway. It wasn't really going to, crawling a manual repository wasn't going to get me close to a really scalable solution. But it was right off. And some of there are a couple other directories on the web. I had to take them off the table. So instead, I've got that little scraper icon there to kind of represent scraping. Instead, I looked at databases of web crawl data that were already publicly available, either on a free or a commercial basis. So things like the Common Crawl, which has, I think, like 5 or 6 billion pages in it. Carnegie Mellon's Dataset, and some commercial crawl databases. These are databases that either have like a complete crawl of the web in a web archive format similar to what the Internet Wayback Machine uses, or they're just a list of URLs that you can go out and you can crawl yourself. So I went out. Yes, sir.
Can you just a little bit more on what the Wayback Machine uses?
So the Wayback, I don't know, I'm not sure what they use for their crawler, but they use an archive file that's also used by a Common Crawl. So it's basically like a glorified zip, basically, where they take, it's not a zip of an individual page, though, it's like a cluster of pages, and you kind of got to open that bucket, find the page you want inside, and then open that bucket, and then there's the HTML and the CSS and whatever other assets they need to display the home page. So in my trying to build the directory and do this crawl, one of the nice things is I don't have to worry about, the CSS or the images or whatnot, because I'm really just interested in the data. And that little meat grinder and cleaver, that's like good programming. I think that's UML actually. So I guess what I'm trying to show is that, first I'd have to collapse all this data, and at this point in time, I'm being a little bit inelegant with what I do with that data, which is what's symbolized by the cleaver. If you had 6 billion web pages that you wanted to examine, and I leverage Amazon for this, so just to sort of get that out of the way. But fundamentally, if you're trying to build a list of APIs, there's probably a lot of clever and interesting ways you could decide, like, when am I looking at a web page that's that's an API page. I mean, stuff like Google, like PageRank, that's kind of off the table, because you don't generally find, you might find in blog posts people saying, oh, hey, I'm using the Amazon API. You might find links to it, but you don't generally, you find a lot of people using an API, but you don't find a lot of static links on pages pointing to an API. But most commonly what you will find for APIs, and nicely, is companies want you to find out that they have an API. So in the footer of the homepage, there'll be a link that says API, or sometimes it says developers or something like that. So people are already kind of helping you a little bit. Then you can look at those pages, and you can imagine if you followed those links, if you crawled a little bit deeper, if you found the words like, REST, SOAP, JSON, chances are that you've probably got a good API page there as well. So that's roughly the tactic that I took. I know from experience, looking at the crawl and looking at what kind of came out of the grinder and the hatchet there at the end, I know that there's definitely some good results that were tossed because of that functionality. And I know there's some garbage that came in. There's other stuff, Advanced Petroleum Institute, damn you, with your acronym, you are not an API. So there's some things like that, and some NLP that had to be done to figure out, okay, is this a blog post about an API, or is it the actual API to try and get the best results? Other thing I just wanted to mention is so without PageRank, what about score? How do you figure out when someone searches for weather and you get 10 APIs for weather? How do you figure out which is the right one? And I'm still tweaking that. As I said, I'm going over for a demo here in a second. But so how do you figure out which ones are the best? Do you go by the amount of times they mention particular keywords? That's not really a good use case. Do you look at maybe the amount of code that's on the page, thinking, okay, well, if they're giving examples, it's probably more robust. There's a variety of techniques I use. There are also some other services that I rely on that I call to try and get, you can imagine, I don't use Alexa, but you can imagine similar services. If you've used Alexa to try and see how popular a page is, you can imagine maybe using that and trying to also say a more popular site maybe is, has a more popular API. Yes, sir.
How do you mentioned one of the things you mentioned was like one version of truth. You have a problem with that. And then the other question is, more of that question would be, how do you go about checking the throttle with these APIs? And then,
meaning how you don't inadvertently create a denial of service attack on the system that you're crawling? Is that the question?
That would be one of the, yes.
So, the stuff that I was doing, both in the previous example and this example, are really not so onerous. I mean, they're actually using the system. Like if you think of the placing an order, I'm not placing any more orders than the system was designed to handle. I'm just making it easy for people to place the orders. And here in the case of crawling so you would assume the system was already designed and tested to handle, Mike ordering a copy of Acrobat. It's not me going to the website and ordering it now, it's this API going to the website and ordering it. In the case of crawling, so here what you have is instead of going deep here, I had to basically, I had to assemble this from the tops of all the icebergs. Again, you're hitting this site like once to just basically get a copy of it and look at what's going on. I don't have the bandwidth to crawl the web like Google does, and you're respecting robots, robot TXT files and whatnot. So you should be operating well within the range of a site's capacity. The challenge is I have a web calendar site on the site. I mean, sometimes you do have pages Like I remember in the early days, Localendar's 15 years old now. In the early days of Google crawling it, it would go to a calendar page and it would be like next month, next month, next month, and it would just sit there because it thought like the thing never ended until they got a little bit smarter about that. But here, you know, I know that I'm only usually going, I think, 4 pages deep, no deeper to find. I mean, if the API is more hidden than that, it's probably not something I'm interested in.
While crawling, and if you encounter a single page app site, how do you then address that?
A single page in terms of, oh, you mean like an Angular app? Sorry. Okay, so in the case of so there's sort of 2 answers for the 2 different use cases here. In the case if I was building an API, I would probably have to look at whatever services that app, Angular or Ember or whatever was using, and I'd probably have to be a little bit, you know, I'd have to be a little bit more of a developer. It's not going to be like something that a power user could do to intuit that. In the case of API Hound, because I'm looking at like 6 billion pages, I honestly would probably just like skip it, because the percentage of those number of sites that are there and the customization I'd have to do for them at this point in time, there's just no payoff for it. Let's see here. So, yes.
Just from experience, if you're working against Twitter's REST API, the first time they kick you off, you'll be so surprised when you realize that you exceeded their limit just because they want you to pay for extra bandwidth. Sure.
Well, keep in mind too, I'm not actually calling any of these folks APIs. I'm only discovering that they exist. So that's, you know, one of the challenges was, you know, a company like, let's say Google, for example, that maybe has like, 50 different APIs that they have, making sure that they actually aren't overweighted in the search, that other companies that have just as useful APIs are included also. So now, as I mentioned, this is, when Eric talked to me, this was really like a week ago. This looked completely different. I've been mostly focused on the data with my 2 other co-founders. So we put this together a little bit quickly here. So if you visit API Hound, I'm sorry, like home and about and stuff won't work. But the search should work. So for example, I should have mentioned, like there's over 50,000 APIs right now. I've still got a few billion pages to crawl. So we're like 4 times beyond what Programmable Web has. So if I search for something simple like weather, I get some interesting results. Now, again, I'm pretty comfortable with a lot of the data that I have. The relevancy is still something that I'm tweaking. So here we have World Weather Online, Mars Weather, My Weather. What I like about this is that Open Weather Map. What I enjoy is finding the little niche sites. Things still sneak in here, like a blog post probably about the Google Weather API. I'm trying to work through the best ways to get rid of that. You have sites like Wonderground. They provide pages that are just different enough because of their translations that I'm not successfully collapsing these. Really, it should just be one site, but they dynamically, much like a lizard at mating time, they like blow themselves up to make themselves look more important. But it's really interesting to find, as I was saying, these little niche APIs that are out there, because Programmable Web has all the big ones. If your company's like some huge company, they made a big API, they probably know to get themselves listed on Programmable Web. Weather API, designed for developers. And we also have tried to categorize these. These are, again, there are APIs out there that will categorize. Unfortunately, they're commercial, but they'll categorize URLs for you. So what we've tried to do is say if someone wants to, grab a specific subcategory, pets and animals, we can, we will try and filter our results to that category. And obviously, we'll let you search within that category too. I came here yesterday just looking for stuff to show you guys. I thought, here's some more bad data. Petfinder.com, 374,000 adoptable pets. And then you go there and you're like, oh, it actually is an API. Okay, there is something there. And it's really fun right now just to play around with it. I'm not sure if, when I want APIs, I'm sure I'll probably still rely on both sites. But back to my previous example about using these APIs, I think we all know the power of this now and doing, sort of mashups and combining different functions. I'll always look for something that I can source externally before I write the function myself. And what I'm hoping to provide, I kind of built it just to see if I could, first of all, and mostly for myself, but I'm actually hoping that, you guys will find some use in it. My email is up there on the site, I think, or I've got cards over here. And if you play around with it and you see, again, beta, my disclaimer, but if you play around with it and you see stuff that you like or don't like, please let me know. So that's kind of like probably, are we kind of dialed into like the right amount of time there? How do we think? What do we think, Eric? Should I wrap it up there?
I think it's ready for QA.
All right, guys. So thanks very much again for letting me to present those two things. We've got kind of the the boring corporate example and the interesting startup example all in one presentation. So I'm happy to turn it over to Eric, who would maybe facilitate a little Q&A.
Before we do that, I just want to give a great big round of applause. Who wants the first question?
Right there. Do you guys have APIs? Like, if I was to go as a Python developer, what can I get?
I'm sorry, what kind of developer?
Python developer.
So I'm actually specifically trying to filter out language-specific APIs, although they have crept in. For example, I was looking at the other day, and there were Pywick APIs and like CouchDB APIs and stuff. So language-specific or library-specific APIs, I'm really not going after. I'm trying to focus strictly on like REST and SOAP APIs. That said, if you wanted to do a search, I have nothing like seeing what happens. We search for Python. Obviously you'll get results back. I can't really promise. I haven't looked at some of this stuff. But you can play around with it and see what's in there. But it's not going to be language specific. It's going to be more like, language agnostic, obviously, because REST or SOAP.
Next question. Yes?
I have a question actually about the corporate side of it. After you built the Omni portal,
Yep.
Did you get any buy-in from the development teams for those 14 sites, or any changes? Like, were any of them interested in saying like, oh, maybe we should open this up and give you an API?
So yeah, unfortunately, no. I mean, they, mostly what we got was a lot of skepticism and criticism and suspicion that we were going to damage their system. It was going to be a denial of service attack. It was going to be invalid. The most changes that one of the systems made was they said, we're going to add a special hidden field, and could you please populate it with like a Y flag so we knew that this came from your system, which was essentially like so that we can blame you when like something goes wrong. And for the other systems, if there was a comment field, we always like automatically said generated by this catalog program. But no, unfortunately, I think. I don't know if there was, if there was some animosity because we had gone ahead and done it, but I think that, it did show them that, look, you could have done this all along. You could have built this system, but no other buy-in beyond that.
But what about the just the user buy-in from the rest of the company?
Oh, the users. You know what? I should have put a testimonial page in here. So I used to give. When I would have my like annual review and things, you would talk about, well, I deployed this system and I saved this much time and this much money, and I stopped doing that because everybody always plays with the numbers. I had tons of unsolicited emails. Let me try and remember some of the things like, this is a tool is a thing of beauty. This was long overdue. It's so easy. I thought I missed something. Something like I can't believe how easy it was. So I would just start showing. I actually on the bottom there's a link to like a testimonials page, and I would just tell people, look. We could talk all day about the numbers and like dollars saved and stuff, but clearly there's like a customer delight element to this that you just can't deny because you can always play around with the numbers. So yeah, the users were very happy with it.
Yes. When you said you worked at a large bank, this large bank could be geographically diverse and spaced out. Where were the main cohorts for the software developers? Were they local to you, or were they distant?
So it wound up. I'll just tell you a quick story in 2 minutes here. Originally, I wanted to do this as a Groovy Grails project, and I was going to be brought on as sort of like the mashup expert and just kind of direct it. This is great. I'm not going to write any code, and I get to order everyone around and see how it works. Well, the Grails thing was a disaster. I went out and we hired some guys that we thought were good, some contractors. We knew it was going to be short term. It's funny. It comes back to like Orm. I knew what the structure of the thing should be. The person was trying to construct these classes and let Grails generate the framework, and it was constantly generating this schema that I knew was like fundamentally wrong. And I would just say, look, this is what the schema has to be to hold it. Your object model is not gonna map up correctly. Well, in the end, it turned out that we had to basically just give up on Groovy and Grails, get rid of 2 of the 3 guys. And I had to step in and write 90% of the thing myself of all the back-end code, and another person did the UI, and another person did the the admin screens. So it didn't work out exactly the way I wanted, but like I said, the delivery time frame was still pretty quick.
But what was the geographic?
So they were all so originally the team was distributed. When I had to step in, it was myself in New York and another person in Colorado, another person in Charlotte. So I suppose still geographically, distributed. In terms of the users of the system, that is global. Generally, our infrastructure has been designed to support that.
But I was more interested in those 14 different projects.
Yep.
Where were they?
They are all domestically distributed across the states in different data centers. So the process of ordering an item, it's still within the levels where users don't complain about it, but the process does vary, both based on the type of system that you're ordering from underneath, because some of them are inherent, some of them are faster than others, and then of course the geographic location of it does figure into that as well. But since for our level, like initial search and exploration of the product catalog, and that's our database, that's lightning fast.
Yes. Just first a comment, then a question. A comment is, you almost created an anti-pattern by making ordering easy in a corporate setting, because the whole point of ordering systems is to basically deny you the ability to spend money.
I never thought of that. That's probably true.
But the question is, did you run into, on the politics side of the house, I mean, it would be pretty easy to essentially crash your system by changing one parameter, one variable, adding, say, a secret salted hash. Did you run into any of that kind of animosity when you were
You know what? No, because luckily it's just as hard to change things for the wrong reasons as it is to change things for the right reasons. So no, we never did run into that. And it's in the book I talk actually about. I do have some patterns, some anti-patterns where I talk about how you can prevent everything that I'm talking about in the first part of the book. And they didn't. Luckily, they didn't put any of that functionality in. But I really think it's just they were so resource constrained. If there was some animosity, there was no attempt or effort to actually reflect in actual code. We may butt heads sometimes, but it doesn't come down to an outright brawl usually.
Continuing on that, you say you wanted to implement in Groovy Grails, so which is, as far as I know, not the preferred environment in large corporations. So how did you overcome that? How did they allow you to implement basically any technology you want? Yeah,
we have a pretty tight governance model, and part of what my team's mandate was to work on innovation. So I kind of shoehorned it under, this is something we're going to explore because it's a low risk project and something that we'd like to vet this technology and see if we could use it. And we had a couple other pockets that had already been approved for use. We had a few other uses of Groovy. I don't think Grails, and I was prepared to take it while we were developing it, to take it sort of through the approval process, and I was pretty comfortable that we'd be able to get it done. But in the end, it just didn't work out, and I can't necessarily blame 100% of it on the technology or 100% on the folks that we hired. It's probably some mix, but we did have a tight deadline, and in the end, I don't know if I mentioned, in the end we fell back into like a Java tool set that we were comfortable with.
Do you have to deal with vendor preferences? Let's say when I look for an item and you go out and you find it in 2 catalogs. How do you deal with that? So generally, there had already been some work to rationalize the catalogs, but we did actually, what we did have is we had some senior managers come along and say, well, I don't want anyone to be able to order infrastructure hardware through this catalog. And which was really strange to me. There was no technical reason. It was really just they had the authority to say, we don't want this stuff in here. And it was really a way for them to make sure that a certain amount of traffic still went to the underlying site, that they protected their groups. So we did take some stuff out. It made me uncomfortable to have to do it. In the end, I was happy. My goal was sort of like that Pareto
principle was I want the 80% of or the 20% of products ordered by 80% of the users. If I can make it easy for them, all right, I'll take stuff off the table. But if I can get 80% of the most commonly ordered products out there, then I'd be happy. And so that's what we did. And where necessary, we did. If the same item came in from both catalogs, it was usually a small enough set of occurrences that we could manually knock it out and not have to worry about like some confusion, like having the same item in there twice.
We have time for just like one more question.
Yeah, I'm sure maybe I fell asleep while you said this.
That's very encouraging. Thank you.
Yeah, sorry. I had a short night.
I may fall asleep when I'm answering your question.
But how did you seed your search? I mean, you started from a list of domains.
Oh, you're talking about
API
HAM.
Yeah.
So a couple of things. So one was, let's just say there were a couple collections of URLs that I had to go out and crawl, and I mentioned on the false slide that I had some commercial calls just like Sphinx and Scrapey and some other things. And then the other source, the other two sources were the Common Crawl database, which is updated periodically. That's an Amazon public data set that anybody can get to, and you can crunch that on Hadoop for free because it's hosted there. And the Carnegie Mellon, I forget the specific name of it, but they have a crawl database also.
So you took these two databases.
Those in the list of URLs, because you have to get some things. You have to do some crawling because at the time when I started looking at this, now Common Crawl is updated. They have a pretty comprehensive database. Now they've updated through October, but they had previously only updated through August. So anybody that's released an API since August, you are not going to have. So it is again like a Google search, right? You've got to constantly try and crawl, maintain, refresh. Right now, what I'm focused on is working on the relevancy of the 50,000 APIs we do have and trying to get some of the junk out. And then having a regular ongoing crawl is definitely part of the plans.
Okay, Mike, hang on with that question. Mike will be here for one-on-one questions, so you'll have a chance to ask it. But we're out of time for tonight. Thank you very much, Mike. Thank you all for coming.